Okay, so let's solve this question. The question states that the binary search tree, that is a BST, represented by T, contains n distinct elements. What is the time complexity of picking an element in T that is smaller than the maximum element in T? Okay, so suppose this is a BST. It is a BST. It follows all the rules that the right subtree must have elements greater than the current root and the left subtree must have elements smaller than the current root. So all the rules are followed. Now the thing is, the maximum element that they want us to find, the small element that is smaller than maximum element. So maximum element we are going to think, and that is going to be 5. The smaller than that is going to be 4, right? And like this, students are going to go on, and they are going to get to a answer of an algorithm that is going to find an element that is just smaller than 5 is going to be is going to have to navigate till 5 and just before than that, right? To navigate till 5 is going to give us theta log n by common analysis, which had been done in BST before also. So 4 is going to be log n only. So the students are going to mark option C, but that is going to be wrong because we have interpreted the question wrong. The question states that the picking an element T that is smaller than the maximum element T, right? We have to pick an element that is just smaller is never mentioned. It is mentioning any element that is smaller than 5, biggest element, right? So the first element over here would more than suffice for that criteria, right? So because as you can see the first element over here, if any right subtree is present, we can directly pick the first element directly, right? If any right subtree is present from algorithmic point of view, as we start the algorithm, we come over here and then we check, is there a right subtree present? There is a right subtree present, so we can directly just return the current element as the element smaller than the maximum element. That is correct. What if there is no right subtree, but there is a left subtree? So we're going to come to 5, check that there is no right subtree. We're going to go to 3, right? Because 3 is going to be less than 5, so this 3 is going to be your answer then. Likewise, if there is no left or right subtree, in that situation we cannot return 5 because 5 is the largest element. We want an element that is smaller than 5. So in this situation, we are going to return null because the element smaller than the largest element is not present in our BS tree, right? So whatever we are trying to do, it is not taking any traversal of the tree, right? Either the first element or the element that's just next to that. That is the maximum extent to which we are traversing the tree, and because no traversal is actually invoked, right? So the number of steps that are actually required does not depend upon the input. N is the number of nodes that are present in the BST, right? Number of nodes present in the BST. So no matter how big the BST be, the result is not dependent upon n. Because it is not dependent upon n, the answer is going to be theta of 1 to find the element which is smaller than the maximum element, and that is going to be your real answer. This is not your answer. The answer is D, right? It was a question in which you make silly mistake because fundamentally human thinking is affirmative in nature. You read the maximum element, you think about 5, and then you add the concept of smaller than that, and then you come to 4. But as you go on reading technical stuff, you come to realization that smaller than and just smaller than are completely different things and must be the distinction of that you would get to know. So they were checking, do you have the concept of BST and also do you have practice of reading technical stuff? Both of them once checked yields you the answer of D very simply, right? With that, I do hope that you learned something. I will see you in the next video. Thank you.